This is a video on using differentials to approximate a percent error. The question states, a six-sided die is measured to have a side length of 2 centimeters with a maximum possible error of 0.05 centimeters. Use differentials to approximate the maximum percent error in the measurement of the volume of the die. So first, let's remember the definition of percent error, which is that percent error is equal to delta V divided by V times 100%, where for us our V is our volume of the die. So since we have a die which is a cube, the formula for a volume is that the volume is equal to S cubed. We're also given that the measurement of S was 2 centimeters and the error was 0.05. We can interpret that as saying S equals 2 and ds equals plus or minus 0.05. We want delta V, and delta V is approximately equal to dV. So we can take a differential and say that delta V, which is approximately dV, is equal to the derivative, which is 3s squared, times ds. So now let's plug in. S is 2, ds is plus or minus 0.05, and we get 3 times 2 squared times plus or minus 0.05. I did the arithmetic, and I got plus or minus 0.6. So we want delta V divided by V times 100%, and that's delta V, which is plus or minus 0.6, divided by V. V is the volume, which is S cubed, and S is equal to 2. So that's why it's 2 cubed in the denominator, times 100%. And now let's do a little more arithmetic, and we get the final answer that the maximum percent error in the measurement of the volume of the die is plus or minus 7.5%. And I'm done with the problem.